So let's talk about, I don't want to talk about counting rules. All right, so we're gonna start here first. We'll talk about counting rows and random variables tonight. We'll probably get to mean and variance of a random variable, hopefully. So when we talk about counting rules are used to find all possible ways that events can occur. For instance, if I have in my closet, if I have 5 shirts, 2 pair of pants, and 3 pairs of shoes, I want to know how many different outfits can I wear? How many different outfits can I create? If I have 5 shirts, 2 pair of pants, and 3 pairs of shoes, how many different outfits can I create? Right. And so what we talk about when we talk about that is it's called a counting rule. And it's actually called the fundamental counting principle. It's a list of different what number of ways that events can occur. And then we can start rearranging things to what we get what's called a permutation, where the order of the events actually matters. For instance, if I run a race with 7 people, what is the way that how many ways can the 7 people medal first, second, and third, or gold, silver, bronze? Where order matters because the first place finish is different than the second place finish, and the second place finish is different than the third place finish. And that's different from a combination where in a combination it says if I have 7 people, how many uh, how many subcommittees of 3 people can I make using the 7 people? Where John, John, Betty, and Mike are the same thing as Betty, Mike, and John. So order doesn't matter there because you have the exact same 3 people. We're just listing them differently. So order doesn't matter there. So as you can see, I don't want to say this, but I hate counting rules. I hate doing this part because it gets confusing. So you have to be able to distinguish between a permutation and a combination. But before we start, that we'll start with what we call the fundamental counting principle. And the fundamental counting principle says if event A has n ways it can occur, and event B has m ways that it can occur. So if I have 5 shirts and A, 2 pair of pants and B, right? Then we can find the different number of events that it can occur together like that by multiplying them. That means that I can make 10 different outfits, 5 times 2. If a woman has three skirts and 4 sweaters, how many outfits are possible? Here is event A. Here is event B. There are 3 ways to wear a skirt, right? 4 sweaters, 3 times 4 is simply equal to 12. I'm going to show you what I mean by that. You have a woman she has a red skirt, she has a black skirt, and she has a green skirt. But I got that. If she wears the red skirt, then she can wear her blue sweater, her purple sweater, her red sweater, or her green sweater. So how many different combinations do I have there? Red, blue, red, purple, red, 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 green. That is 4 total ways she can do that, right? I can carry that to here as well, right? Because she can wear blue, purple, red, green. How many ways would she have to wear that? 4 again, right? I can also carry that here where she can wear blue, purple, red, green again. That is 4 there. If we add these up, we get 12. So the fundamental counting principle, or FCP, just says instead of doing all that, then there are 3 ways for event A. And there are 4 ways for event B. And that's equal to the 12 we got there again. So all it says is you take the options, you multiply them together, you get the number of ways you can do it. That's all it says. And that's what we start at with the fundamental counting principle. Now, here's another example. Paint manufacturer wishes to manufacture several different paints. The categories include the color, the type, the texture, and the use. How many different kinds of paints can be made if you can select one color, one type, that should be one texture. It should be one texture and one use. How many colors are there?
7.
Okay, I just want to make sure I was still there. 7. How many latex? How many types are there?
2.
Thank you. 2. How many textures are there?
3.
3. And how many uses are there?
2.
2. So how many different kinds can you make? This would be 7 times 2 times 3 times 2. Right?
This seems too easy. When's the curveball coming?
Yeah. So 7 times 2 times 3 times 2, what's it equal to?
84.
84. Thank you. That's just 84 different ways, or 84 different types of paints you can make. I used to go to Sonic a lot, and Sonic used to always have the drink specials about how many drinks they could make. You know that? Like during happy hour, they can make this many drinks. They do that by just multiplying all their probability, all their different like syrups and types of drinks and flavors and, things like that. So that's what they're doing. It's fundamental counting principle. It's used often, actually. Now, we're going to extend it a little bit here, and we're going to say this. Texas license plates have 4 letters followed by 3 numbers. Assuming repetitions are allowed, how many license plates could be issued? So their license plates have 4 letters followed by 3 numbers. So let's draw this out. In a Texas license plate, you would have 1, 2, 3. Those are all letters. These are your numbers, right? So the question becomes this, how many ways, first off, how many letters, there's 4 letters, right? How many letters do we have to choose from then? It's the first question I want to ask. How many letters do we have to choose from?
26.
I heard 2 different answers. There's 26 letters. There's 26 letters. So in this first blank, then there are 26 different options that I can use. In the next blank, there are also 26. The next one, 26. And the last one, 26. Then you have 3 numbers. And again, this matters, by the way. They say that repetitions are allowed. Because repetitions are allowed, that's why we have 26 times 26, 26, 26. How many numbers are we going to have?
10.
10. So there are 10 numbers, 10 here and 10 here. 0 through 9. Those are 10 numbers, by the way. Right? Now, multiply that out, then what do you get? That's how many numbers you have. That's how many license plates you can make. That is 456,976,000 license plates that can be made. It's a lot of license plates. What if repetitions are not allowed? How does that change things?
It would
How
go
would they change things?
25, 24.
All right, cool. So this would start off with 1, 2, 3, 4. Then the numbers 1, 2, 3. So it'd be what then? 26, 25, 24, 23. This would be 10, 9, 8. Right? So we have 26 times 25 times 24 times 23 times 10 times 9 times 8. Here I get 2, 5, 8, 3, 3, 6, 0, 0, 0. So this number, 258,336,000 license plates. Notice that when repetitions are not allowed, though, you get a reduced number. Now, this is going to lead us to a concept. All right, it's going to lead us to the permutation. And what it says is that if you look at this first spot, when we started this, there were 26 ways to rearrange those 26 letters. Everybody got that? Once I put a letter in this blank though, how many letters do I have left? How many letters do I have left? So let's say I have one less. So I have A right here. Let's say I put A right here. I no longer have the option of A, right? So I only have 25 letters to choose from. Let's say I put B right here. If I put B right here, no longer have A or B to choose from. So that means I have 24 letters. If I put C right here, I no longer have C to choose from. So now I have 23 letters. And so what this is saying is that I'm reducing the number of ways I can rearrange things because I'm using things up. And we're going to get to this thing that we call a permutation, right? A permutation. And a permutation is an arrangement of n objects in a specific order. Right? So here's what that means with an example. Professor has 5 books: history, chemistry, biology, physics, and calculus, all on his shelf. How many different permutations of the book can be ordered on the shelf? Right? So to explain what a permutation is, let's say he has history, should be more unique letters, 5 books on the shelf. On that shelf, he has the books, history, chemistry, biology, physics, calculus. This is one ordering of those books. Is that the same ordering? Here's a new ordering: 1, 2, 3, 4, 5, as chemistry, history, biology, physics, calculus. Is that the same ordering? Yes or no?
No.
No, they're different, right? Question is then, how many of these different arrangements can you get? How many of these different arrangements can you get, right? And it's actually a pretty simple thing to figure out, because here's what happens. If I have 5 available spaces, right? And let's say I let this first one be history, right? Or if I look at just the first space, what book can I put on my shelf there? What book can I put on the shelf there?
Any of the 5.
Any of the 5. So I can put history, I can put chemistry, I can put biology, physics, or calculus on that shelf first, right? But then what happens next? After I put a book on there, what happens? The next spot only has how many ways to rearrange that book? 4. After I put that, what happens next? The next spot only has 3, followed by 2. And there's only one way to rearrange the last book because it's fixed now. So if we multiply all of these, 5 times 4 times 3 times 2 times 1.
120.
Thank you so much. That is equal to 120 ways to rearrange these books on the shelf. 120 ways to rearrange these books on the shelf. I'm listening.
Sorry, I have a quick question. So basically, does
Before.
permutation mean no repetition?
Yes. You can
Okay.
think of it like that. Yes. That's a way of saying it. Now, this formula is going to be introduced through what we call a factorial. A factorial, you may have seen it, you may have probably have not. A factorial is the exclamation point in math. It's the exclamation point. And we call it n factorial. And n factorial says this: when you talk about a factorial, n factorial is equal to n times n minus 1 times n minus 2 times all the way down to 2 times 1. That's what the factorial says. So 4 factorial, for instance, is 4 times 3 times 2 times 1. 7 factorial, 7 times 6 times 5 times 4 times 3 times 2 times 1. And then that leads us to our permutation formula. Permutations, you don't really need a formula, but this is the formula. It says n factorial divided by n minus r factorial. N factorial divided by n minus r factorial, where n and it's the total number of objects you have available to you. So in our case, we have 5 books. We have 5 total books available to us. Or R is the number of ways we want to try to rearrange those things. In that particular example, there wasn't an R, right? But generally speaking, there will be some kind of R depending on certain things. But it's called NPR. We say NPR. And it's equal to n factorial divided by n minus R factorial. So it's n factorial divided by n minus R factorial. I'll be honest, I don't even remember the fact. I don't remember the permutation formula because I don't use it that much. When I do a lot of permutations, I do exactly what I just did with y'all. I just draw blanks and I figure it out from the blanks. But the blanks work. But this is the formula. It's a simple formula. I should remember it. I shouldn't tell you I don't remember that, but I don't. That's okay. It's called problem solving. So here was an example. 8 people run a race. How many ways can we award first, second, and third place prizes among the 8 racers? If 8 people run a race, and let's say that is, let's say we have Ashley, Betty, Cameron, Dave, Eric, Frank, Grace, and Henry running a race, right? So that means I have these people running a race: A, B, C, D, E, F, G, and H. All the people run a race, right? I want to know the different ways I can rearrange first, second, and third. My question is this then: if I do an ordering of A, B, C, is that different than B, C, A? Yes or no?
Yes.
Yeah.
Yes, that is different in this particular case because this means what? A got first, B got second, C got third. Here, B got first, C got second, A got third. So this is different because they are different, because the order matters. This is called a permutation. In this particular permutation, your N is the total number of people you have available. So to us, our N is equal to 8. And the R is the number of ways you want to rearrange those 8 people. Well, we want to rearrange them in 3 different spots. So our R is equal to 3. So when we write this, we can write this as 8P3. 8P3. And again, the formula is NPR, where this is equal to n factorial over n minus R factorial. N factorial over n minus R factorial. So calculating this, I get 8 factorial, that's your n, divided by 8 minus 3 factorial. So this is just 8 factorial divided by 5 factorial. Factorials are really cool in terms of like the simplification process that you go through. I mean, they're cool to me. They probably won't be cool to y'all. They won't be cool to y'all, but to me, they're kind of fun. Because what does 8 factorial mean? What does 8 factorial mean? Somebody tell me what 8 factorial means?
8 times 7.
6 times
Good.
5.
7 times 6 times 5 times 4 times 3 times 2 times 1. What does 5 factorial mean? 5 times 4 times 3 times 2 times 1. Look what happens here. What happens? I was supposed to cancel the 2. Those are all canceling out, right? So what is 8? What is this really equal to? 8 times 7 times 6, which is just 8 times 7 times 6. There are 336 ways to rearrange first, second, and third if 8 people run a race. Now, why do I say I don't remember the formula for a permutation? Because I would have did this problem just like this. How many places are we trying to fit people into? First, second, and third, right? First, second, and third. How many ways am I trying to rearrange the first spot? How many people to look at?
8.
8. Once one of those people finish first, the next person, how many ways can they finish second?
7.
7. And then once that person finishes second, how many ways can I rearrange third?
6.
Which is still what numbers? 8 times 7 times 6 without the formula. Permutations are very simple if you can pick up on it as a permutation. That's the hard part. These formulas themselves aren't hard at all. It's actually distinguishing which one is a permutation and which one is a combination. And the only way you get better at that is you practice. I'm gonna be honest, I struggle with it. And I teach it. And I'll be honest, if you sometimes you ask me a question, I'll just be like, you might be right. But I'm gonna confidently say it, whatever it is, all right? So if it's wrong and I back up and I backtrack, don't get mad at me. All right. Batting order for 25-man Major League Baseball team consists of 9 players. How many different lineups can be submitted by the skipper? Question, does that order matter? It's called a batting order, by the way. So
Yes.
yes, your order probably matters there, right? Putting a person here versus there is going to be a different spot. So even though you might use the same 9 players, if you put them in different spots, that's different orders, right? So again, we can use the formula. The formula says this. I have how many things? 25, right? So this is going to be 25, 25p, and I want to use 9 players, so 25p9. That's equal to 25 factorial over 25 minus 9 factorial. So 25 factorial over 25 minus 9 is
16.
16. Thank you. 16 factorial.
So
So the question is, where do these start canceling out at? That's really what you're going to ask yourself. Where do you start canceling out at? They start canceling out at what?
16.
16. So you would have 17, 18, 19, 20, 21, 22, 23, 24, and 25 you're multiplying. Or again, we could just draw blanks, 9 blanks. 25, 24, 23, 22, 21, 20, 19, 18, 17. I'm showing you this way. I'm showing you the formula because I want you to see why the formula works. I'm not expecting you to do the formula though. I wouldn't do the formula either. I would just draw blanks. This is not a fun calculation, by the way. There you go. That's a huge number. Get this back. This is 7, 4, 1, 3, 5, 4, 7, 6, 8, 0, 0, 0. 3. What's that? 741 billion, 354 million, 768,000 different ways to rearrange this. That seems kind of absurd. Hey, so I know I should be showing you this in Excel too. Excel has a permutation formula, by the way. It has a permutation formula. Let me bring that up. Because how many of y'all are using calculators? I don't know if y'all using calculators or y'all using Excel. What are y'all most y'all using? Calculators or Excel?
Excel.
Later.
All right, let's go to Excel. Let's go to Excel. If you don't have a calculator, your calculators actually have I'll show you in mine. I'm using the TI-83, but mine has a permutation formula. It's located under the math button and PRB. And you see it right there, number 2 is NPR. And the way you type it in, I think you have to type in N first. So I'll type in 25, math, PRB, NPR. So it automatically 25P3, 25P9. There goes that big number 2. That's a calculator. Most, if you have a graphing calculator, most of them will do permutations and combinations. They're generally located under some kind of statistic or probability button though. So you have to look for it. In Excel, go to Excel and look at it what it looks like in Excel real quick. You see, you have permutations right here. Permutation A, I think is this one. You see how it says the number? So I'm using per mute, I guess that's what it says. Number, that would be 25. Number chosen is your R, that's 9. There you go. Can't see it because it's such a big number, but it's to the 11th. I'm not going to tell you what that is. So to the 11th means you have 7.41355. It's a really big number, is what that's saying. All right, let's do a small one. Let's do one we can actually calculate. Let's do the one we did above it. 8P3. 8P3. Let's permutate that. So equals permute. I want 8 things. I have 8 people running the race. I want to choose 3 different spots. 336. So just PEMRUT. I wonder what that other one does. Let's see. Permutation A. 8. Don't use that one. That one was not right. I don't know what that stands for. Use the first one that we did. All right. Hey, any questions on that one? Any questions on permutations?
No.
All right, let's move to combinations next then. Let me get the screen back. Now, a combination is different than a permutation. Combination is different than a permutation because here the order does not matter. Here my order does not matter in a combination. Where is my screen? Oh, stop share. There we go. So in a combination, the order does not matter. Therefore, AB is the same thing as BA. Which means because order doesn't matter, you should always have less combinations than you do permutations. Permutations are unique. Combinations are not. That's how we say that. The number of combinations will always be less than the number of permutations. Always less. Because you're taking on, here's how the formula works out, by the way. Really what you're saying here is there are in factorial ways to do everything. And so for instance, with running a race, there's 8 different ways that people can finish in the race, right? But then what you start to do when you do the N minus R part, the N minus R, you're looking at, well, I want to take out I want to eliminate the 5 spots that I'm not interested in. So 8 minus 3 was our 5. If we eliminated the 5 spots that I wasn't interested in, I'm only interested in those 3 spots now. The combination is different because now it has this R factorial. And what R factorial is saying, well, now I have 3 spots. How many different ways can I rearrange those 3 spots? I can rearrange those 3 spots R different ways. So it's a different formula, but it's basically based on the same concept. The thing you need to know, though, is you need to be able to establish the difference between a combination and a permutation. They are different. So let me write out the formula again before we start this. We have N, C, R. That equals to N factorial. This one's a little bit different. I don't think you can use, I don't use blanks for combinations, which is why I remember the formula. N factorial over R factorial times N minus R factorial. What am I doing? That should be R factorial. There you go. Now I want you to realize that you have your permutation formula sitting here. You're multiplying the bottom by R ways. You're throwing away the ones that are repeating. That's what this is saying. Throw away the repeats. For a segment of a radio show, a disc jockey, Dr. Jams, can play 4 songs. If there are 8 to select from, and how many ways can the program for this segment be arranged? So what they're saying is that there's this program, basically, I guess an hour-long segment. He has 8 songs to choose from. He's going to play 4 songs. If he plays song A, song B, song C, song D, That's the same thing as I'm playing song B, song A, song C, song D. It doesn't matter the order. He's playing the exact same 4 songs. He's just playing them in different order, but that order doesn't matter here. Because the order doesn't matter, this is called a combination. And when you calculate a combination, you actually have to use the formula. So when we calculate this combination, it is my N here. There are 8 songs to choose from. My R here, there are 4 different songs that I want to select. The number of combinations, this is 8 C R, is equal to 8 factorial divided by 4 factorial times 8 factorial minus, oh, not 8 factorial, I'm sorry, 8 minus 4 factorial. Calculating this then, 8 factorial, or let's clean up the bottom first. So the bottom is 8 factorial over 4 factorial times 4 factorial. That's what the bottom works out to be. 8 factorial times 8 minus 4 is just 4, so that's 4 factorial. Right. What is 8 factorial though? 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. What is 4 factorial? What is 4 factorial?
4 times 3 times 2 times 1.
Just making sure y'all still live, man. I'm tired too. We're gonna rock this out. We're gonna finish this one up. We almost done. I got y'all. I'm well with y'all. I want to give up too. 4 times 3 times 2 times 1. There we go. Right?
Right.
So here's what's gonna happen. Look what cancels. This and that cancels, right? And then this is why I like factorials. This is why I have fun with them. You can try to make other things cancel. For instance, I have a 4 and a 2 right here. 4 times 2 is what?
8.
8. So look, this and this will cancel, right? 6 and 3 have a factor in common. They both have a 3, so 6 and 3. 6 divided by 3 is 2, so I have a 2 up here. So it simplifies to be 7 times 2 times 5, which is just 7 times 2 times 5 is 70. Now, do I expect y'all to have that much fun with it? Not at all. So on this, I go to Excel and use the combination formula. Let's go to Excel and use that combination formula real quick. Let's go find that one. So we're going to do 8 combined 4 things, right? Is it 9 o'clock yet?
Almost.
Hey man, y'all know I looked at my watch. I looked at my watch and it was 8:45. I said, "Oh, we got 15 minutes left." I don't know how y'all do it. I admire y'all. Some of y'all been at work all day and gotta come do this. Great job.
Please don't. I slept on you at least twice. I'm sorry.
All right, so here, combination formula. Start typing it in. Here you go. Combination number 8. Number chosen 4. 8C4 combination. There goes your 70. All right. So you have the permutation and the combination formulas in Excel that you can use. They're very easy to use. You give it the N and then you give it your number chosen, your R, your N and R, right? And again, if you didn't see that, one more time. Look at the next one real quick before we start. Before I do it, it says an election ballot asks voters to select 3 city commissioners from a group of 6 candidates. And how many ways can that be done? Well, you're selecting 3 commissioners from 6 things. The commissioners don't really matter what order they come in. So this is a combination again. So for this one, your N is 6, your R is 3. So we're doing 6 C3 this time again. And 6C3, so I'd go, I do every combination in Excel, to be honest. So 6C3, combination formula, 6, 3, you get 20. There's 20 ways to do that. I think we'll go ahead and stop there. Y'all good for tonight?
Yes.
Yes.
Yeah.
Yeah.
Hey man, y'all don't say it like that, man.